OSI and TCP IP models. Now, the OSI stands for Open System Interaction. It's one of the most important topics you should know because there are a lot of protocols and properties, starting from the physical layer to the application layer, where we can see the web apps, programs, etc. You will keep facing the OSI in cybersecurity or network troubleshooting or network engineer or cloud. If you worked in any of these industries or if you work as an IT in general, you will definitely come across with one of it because these are the packets that you send and receive. The OSI model is a conceptual framework that describes how communication takes place between multiple devices or programs. It is not an acronym or a term, but rather a model. The OSI model was designed to replace the need for different network architectures, allowing computers and softwares to communicate to each other no matter what operating system they use. The OSI model is split into 7 layers. Each layer has a specific purpose and performs a particular task that helps transfer data. These are the layers. Now, when you send something, the layers got encapsulated, and when it arrives, it got decapsulated. Now, let me talk about the layers real quick. So let's start with the physical layer. The physical layer at the bottom of our OSI model, we have the physical layer which represents the electrical and physical representation of data. This layer doesn't work with logical structures, but rather with bits and bytes. The job of this layer is to encode the data, as you can see, the bits and bytes. On the data link layer, the data link layer 2 provides the mechanism to transfer data packets between two directly connected nodes. The data link layer also handles error checking of packets that are sent over the network. Each network card or interface is required to have a unique media access control, which stands for MAC addresses, and I'll talk about the MAC addresses later. On the network layer, network layers are where routers live. They take information from the physical and data link layers. Then they make a decision on how to forward packets to their destination. This allows data to reach its destination in most efficient way possible, like let's say your computer in London and you want to connect to a server in the US or Canada or whatever, but there are millions of different paths to take. So routers at this layer help to do this efficiently. Now in the transport layer, here where data get transferred, whether it's a TCP or UDP. What's the TCP and UDP? So TCP and UDP work together to send data from a client to host based on destination IP. Now the TCP is more reliable than the UDP, which is best used for time-sensitive application like gaming, calling, video calls, on any online app, for example, WhatsApp or Messenger. So it is a UDP protocol transport call. If it was TCP, there will be a delay until the three-way handshake established. And I'll talk about the TCP and UDP in the next lecture. Now the session layer is responsible for the establishment, coordination, and termination of sessions between applications. This layer also handles a setup, breakdown, and synchronization among the various devices in a session. It provides for authentication, privacy, and integrity for the data in the session. The presentation layer prepares data for the application layer. It defines how two devices should encode, encrypt, and compress data, so it receives correctly on the other end. The presentation layer takes the data transmitted by the application layer and prepares it for transmission over session layer. So if the data needs to be encrypted or compressed, then the presentation layer will perform that task before transmitting the information across the network 7 session layer. Now the application layer is used by end user, which is a software whom us, such as web browsers and email clients, like the end devices that we use, the interfaces that we see, like web browser software, emails. So it provides protocols that allow software to send and receive information and present meaningful data to users. So a few examples of application layer protocols are the hypertext transfer protocol, which it's the HTTP, HTTPS, the FTP, SMTP, the simple mail transfer protocol, the SSL, which stands for Secure Sockets Layer for websites, And what else? SSH, the secure socket shell. Now, let me show you a comparison between the OSI and the TCP IP. Now, the TCP IP and the OSI model are the same, but the TCP IP has only 4 layers, and both they do the same thing. But in real world, actually, most of the people talk in the TCP IP because it's easier to use. Like if we were talking about MAC addresses or Ethernet cables or Wi-Fi or switches, we would say physical addresses. Now, TCP/IP prepares and forwards data packets over a network, and it is the most frequently used communication protocol. Now, the OSI model is a conceptual model that characterizes and standardizes a computing system's communications function. Now, when we compare the OSI model and the TCP/IP model combines the application, presentation, and the session layer into a single top layer because they work at the same layer. Like imagine 2 or 3 doctors get into an operation room to do a surgery to a patient. So each one of them do their duty in order to finish the surgery successfully. So the same thing happens in here. Layers work together in order we send and receive data successfully.